Hi everyone, my name is Jose and welcome to my channel. In today's video, we are going to talk about Python, more specifically 7 tips on how to improve your code standards. This will be part 1, which contains the introduction and 3 out of the 7 tips. The video will cover basic standards to aim for, as well as some optimization and design techniques when writing your logic. If you are just starting out your Python journey or you've been looking for ways to improve your Python skills, then this video is definitely for you. I hope you enjoy it and find it valuable. Let me know what you think about it in the comments below. I usually find new topics easier to understand with specific real-life scenarios. As such, we'll be exploring an ETL job, extract, transform, load, from a company that produces and sells car parts to different customers. The ETL job receives both the customer's orders and the list of car parts in a CSV file, and we will need to generate 3 outputs. The first output is a file containing the initial customer's orders, enriched with total volume for each order and the factory where the order will be sent out. The second output is a file that contains all orders items split into separate rows associated with the rank. The file must contain the order ID, the rank of the item within the order, and the item code. The third output is the number of times each car part has been ordered. If we have a look at the input files, we can see that the car parts are described by a unique car part ID, a car type, which can be SUV, sedan, van or sports car, a category of the car part, usually a chassis, transmission, engine, clutch, the dimensions, the shape, the price and quantity. Moving over to the orders, these are described by an order ID, a customer ID, the car type of the order, and the car parts and delivery day. The car parts are composed by the category abbreviation plus the car part ID. For example, the abbreviation of engine is simply EG. We have 3 factories and each one of them accepts orders for specific car types. This means that the same customer may have different orders associated with different types of cars. And lastly, the sorting of the orders must take into account the delivery date and the factory. Now that we are aware of the requirements and we have some context on what the business needs, let's have a quick look into our code. The car parts file is the main file that runs all the functions necessary to perform the tasks at hand. We are also able to specify which environment we want to consume and send data to, either staging or live. For that, you should have the end file with the variable live run that is set up to be true or false. Going through the different steps, we can see that we start off assigning a factory based on a settings file. We then proceed calculating the individual volume of each car part, which is used afterwards to calculate the overall order volume. This is done by the calculate volume and the calculate order volume functions respectively. For the orders output, we are left with the sorting of the file performed by the sort orders function. The bulk of the work is done at this point, and now the focus is twofold: creating the individual car parts file, which contains each car part of the order associated with the rank, and create the car part count file that lists the number of times each car part was ordered from the initial file. The utils module contains all the main and auxiliary functions. Feel free to have a look at the code using the link in the description below. Lastly, the settings file contains the paths for the staging and live inputs and outputs, as well as the car type and factory settings. For the car type settings, we can see the mapping between car type and factory. And for the factory settings, we can see the priority mapping that tells us how orders should be sorted. Hopefully this overview makes it easier to understand how your code base is organized and what we aim to do from a business perspective. The link below provides access to all the inputs and output CSV files, so feel free to have a look at them. Alright, I think we are now finally ready to have a look at the tips. So the first point we'll be looking at is the settings file. The settings file is usually where you save your business logic or your pipeline configuration. In our case, we have 2 examples of this. So we have car type settings and factory settings, which are business related, but we also have a staging and live input paths. This can be in different files. For this example, and just to make things easier, we have everything in a single file. So the first thing we'll be looking at is the staging and live configuration. You can see here that they are essentially split among these 4 inputs and outputs, and we'll be aggregating them. So a very quick thing that we can do here is replacing these values by this. Now we can see that the input and output path stays the exact same, which means that you call them in the same way in your code, but the values change accordingly. And so you want to keep this sort of standardization, so it's easy for you to replace configurations in your code. The second thing we'll be looking at is the actual business logic we are using. So we have a car type settings and a factory settings, which is all good. However, we can be a bit more descriptive in the actual configurations we are using. And so for these two particular examples, in the car type settings, we have a factory mapping, but in the factory settings, we have a priority mapping. And so that's exactly what we'll be doing. And so this can be easily changed by updating these values. You can see now that we have a slightly better context of what's going on, both in the business logic and also in the staging and live configuration. So you can clearly see that staging and live share the same configurations, it's just the values that changed. And also in the car type settings and the factory settings, you have an explicit mapping, which we are trying to cover. Just out of curiosity, you could have everything in the factory settings. So you could have a priority and a car type associated. And so if you wanted to do this, you'd probably do the following. So although this is not wrong per se, this will make your life a little bit harder when you try to assign values, factory values, for instance, because essentially you need to pick up on a specific subsetting of a specific factory, and you need to apply that factory. So this would be the values that you have in your orders, and depending on these values, you need to apply the correct factory. You can do it, but if you try to build a dictionary based on this, you'll see that it's slightly more complicated. Also, it does not have readability, and so in the future, in 1 year time, if you need to have a look at the code again, I highly recommend you to keep both the settings file and the code as simple as possible. Let's just remove this for now, and also let's have a look at the changes that we need in the code in order to accommodate this new setting standardization. So moving on to our main module now, we can see how the changes that we've done in settings impact the code. Let's start off with the live and staging environments. We have something in the beginning, to read the files, but also something at the end to upload the files. The changes that we'll be making here will be very straightforward. So let's just replace this if-else logic with the general run configuration. The if-else logic is done for a single variable now, and it contains both the input paths and output paths for live and staging. The remaining of the code will be more general, and we don't have to specify if it's staging or live values in the strings. So this will simplify things a little bit. Also, it helps with the readability of the code. So we do this for the first part here of the module, but we can also do this for the last part. So now we can also replace the outputs very easily. And see, just like that, our main model is simplified a little bit. And remember that in the future, if you want to change values, you can change them in the settings file, but you don't need to do anything here in the main module, which is the main advantage. Now that we've updated the pipeline configuration, let's have a look at the business logic and how our changes impacted the code. The business logic within the settings file impacts two functions here, which is the assign factory and the sort orders function. And so here what we are doing now is just giving the full settings dictionary to the function. And so the first thing is, let's be more explicit on what the function should be actually reading. And so here we can just add the exact keys that we want to give to our function. So let's do that. Now that we are explicitly giving it the factory mapping, we can go to the function and just also change the settings that it's expecting to receive. So now it won't receive the full car type settings here. It will just receive a factory mapping settings. So we can change this name to be more explicit and directly map the value. We can do the exact same thing to the sort orders. So let's have a look. The sort orders currently uses the priority mapping, which we can also change here. Similarly, let's go to the sort order function and update these settings. So now we are actually using a priority mapping here. And let's also apply it here in the map function. So this pretty much covers the changes that we had to do to our code base. The code is simpler now. We also were more explicit on the exact variables that the functions are using, which is always helpful. So now it's time to go to our tip number 2. For tip number 2, we'll be using the typing library in Python, or type hints. I would say this is a fundamental step in your journey to write better Python because it allows you to specify the type of data that a function or class are expected to handle. As you may or may not know, Python is a dynamically typed language, which means that the type of a variable is determined at runtime rather at compile time. This can make it challenging to write code that is free of type errors, especially as the size and complexity of your code base grows. Using type hints provides several benefits. You have better documentation and readability on your code. Specifying the type of a variable or function argument is one of the best ways to make your code more self-documenting and easier to understand for yourself and for other developers. You'll also have fewer bugs in your code because you'll be able to catch errors before you execute it. You can use tools such as MyPy during the development phase to accomplish this. Lastly, it will be easier to maintain your code. As your code base grows larger, it can become difficult to keep track of all the data types that are being used. Type hints will make it easier to understand how the different parts, the different pieces of the code interact with one another, and it will be easier for you if you want to refactor or if you want to expand your code. Overall, using the typing library can help you write more reliable, maintainable, and understandable code. Before we start changing our code, let's go over some points. Python comes with what we can call primitive types. We do not need to import these types via the typing library. A few examples of primitive types are the integer, float, string, and boolean types. We can quickly have a look at an example in which we create a string, but this time we introduce typing. So usually you would create a string like this in Python. However, you can always add the typing here. So this is essentially typing, and we'll be doing this for the different sort of variables that we have in our code base. All other types such as dictionary, lists, tuples, sets, and many more are imported via the typing library and are considered non-primitive. You can also import special keywords such as union for cases when your function or variable accepts more than one data type. The typing library does not include custom types such as the classes you create or import from different libraries. However, I highly recommend you also include them when working on type hints. Now, if we have a look at the inputs and outputs of our functions, we can see that most of them handle data frames and dictionaries. Assign factory, for example, uses as arguments a data frame and a dictionary. In this case, the data frame is the orders data frame, and the dictionary is a mapping that contains the car types and the factories. The calculate volume function needs and also returns a data frame. And throughout the script, we can see a similar logic being applied to the other functions. The only exception that we have here is the getCarPartCount function, which returns a dictionary. We can now go into our functions and start to apply the type hints. So in this first case, the assign factory, we've seen that orders would be a data frame, and the factory mapping would be a dictionary with strings as keys and strings as values here. So if we have a look at our settings file, we can see the factory mapping. We have car types, which are string, and also the values, which are the factory names, are also a string. As I previously mentioned, the dictionary type is not a primitive type, which means we'll need to import it using the typing library. To apply the dictionary type hint, we simply must call the dict key, followed by the keys and values of the dictionary. In this case, we have both string for the key and the value. You can see here that the dict is not recognized, and I also have an error because I've poorly imported the library. So let me correct this. And now we just need to import the typing library, specifically the types that we are using. Now we simply must specify the return data type, which in this case is also a data frame. We now have our first function with both the arguments and the return data types specified. The calculate volume function is very similar to the first example, so we'll just replace the values. The shape to volume function is just an auxiliary function that we use to calculate the volume depending on the shape of the car part. In this case, we are applying a row by row operation, which means that each row that goes into this function is just a data frame with a single row. It's important to mention that this time around we are just returning a float, which is the volume of each car part, and not a data frame or a dictionary. For the calculate order volume function, we use both the orders and car parts data frame, and we return the orders with the new column, which is the orders volume. One thing that we can now have a look is if we go to the main script, we'll be able to see that assign factory now uses as the orders argument a data frame, and for the factory mapping, it's a dictionary in which the key and values are both strings. The calculate volume also specifies the data type, but if we hover a function which hasn't been modified yet, we can see that both the arguments and the return statement are currently set as any. Coming back to our functions, we are now going to modify the sum list values, which is receiving a row, a data frame, again with a single row, and the code to volume dictionary. The code to volume dictionary is simply a dictionary which contains the car part code as keys and the volume as dictionaries. Keep in mind that this time around the dictionary values are not composed by strings but by floats instead, and we are also returning a float in this case. The float that we are returning is simply the sum of the volume of each car part in the specific order. The sort orders function follows a similar logic in which the orders is still a data frame. However, the priority mapping is the priority that we have for each factory, which means that the keys are strings corresponding to each factory, and the priority, the values, are integers in this case. We'll be returning the same orders data frame, simply sorted in a different way. Both the argument and return variable of the create individual parts file function is a data frame, so we can quickly change that. The get car part count function receives an orders data frame and returns a dictionary in which the key corresponds to each unique car part code, and the value is the amount of times that car part code is present in our orders data frame. Lastly, our YAML to dict function is a function that reads any type of dictionary based on a path that you give them. The file name is simply a string, and the return argument is a dictionary in which both the keys and values can be anything. For this use case, the typing library has the keyword any, which we can use here. If we look at our functions now, you'll see that it's much easier to understand what arguments are being used in each function and also what each function returns. And so you'll have much better visibility and readability over what goes into what. Hopefully, now it's clear to you how using the typing library can help you write more reliable, maintainable, and understandable code. I highly recommend you that you have a look into the typing library documentation, because you will find tons and tons of useful examples that you can use to help to improve your code. For tip number 3, we'll have a look at to sort data by complex criteria using the key parameter. If you ever built an application before, you've probably had to sort data at some point. Sorting data is important in applications because it allows for efficient searching and analysis of information, which ultimately improve your system performance but also user experience. In our car parts business, our stakeholders are expected to receive the orders sorted by factory and to be in ascending order of delivery date. The complex criteria lies in the factory order, as it does not follow the alphabetic order or the reverse. Before we go to our function, which sorts values within a data frame, it's useful to understand how we could tackle a similar problem using the sort built-in function. The sort built-in function is specific to certain mutable data structures, such as lists and arrays, and even strings, which have an inherent order. In this example, we have a class factory that contains the delivery date and factory name attributes. We've created a list that contains several instances of the factory class, and we want to sort them in a similar way. We also add our priority mapping dictionary to make things easier. At the bottom, we can finally see how to sort data by using the key parameter. There are a few things to notice here. The delivery date is called before the factory, which is the opposite order when working with the data frames. Also, for the factory sorting, there is no need to use the map function. The mapping is automatically done by getting the values for each of the keys within the priority mapping dictionary. The keys of the dictionary correspond to the factory attribute values of our factory instances. And so now let's have a look at the result. So we can see here that the delivery date is organized by ascending order, but also within each delivery day we are expecting the order of the priority mapping dictionary. If for some reason you want to reverse the sorting order, you can resort to the reverse keyword. Just keep in mind that the reverse will be applied to all the fields. You can, however, reverse the order of a single field using the minus operator. Be mindful though that the field must be numeric. For instance, we can apply to both the current fields because both the delivery date and the values of the dictionary are numeric. Let's have a look at the result. As you can see here, both the delivery day and the factory priority have been reversed. If we would apply directly to a non-numeric field, such as factory, we would get an error. Let's have a look at that. As you can see here, you cannot apply the minus operator to a string field. Alright, now that we know more about the sort built-in function, let's go back to our example. So, before we check if the code works, it's important to mention that one of the advantages of using the sort values when working with data frames is that for more simple use cases, you can specify a list of Boolean values for the ascending parameter. Each Boolean in the list applies the individual reverse logic for each of the fields being sorted. Note that the ascending parameter in the sort values function is analogous to the reverse parameter in the sort built-in function. This is how you do it. On the other hand, one of the big drawbacks of using the sort values function is that if you need to map one of your fields, that mapping is going to be applied to all the fields which you are sorting by. This means that if you only need to map a specific field, you are better off splitting the fields by calling the sort values function multiple times, as seen in our example. Now that we know some of the variables at play, we should see if the code actually works. Let's try it out. So I'm debugging the code, and the code is just stopping after the sort orders has been run. So as you can see here, we have the meltdown factory in first place, which is a good sign. And then we have the radiant rims. However, if we go a little bit below, we can see that after radiant rims, we have ForgeWorks, which is still good. But afterwards, for the same delivery day, we have the radiant rims again. So this means that the sort function didn't work properly. This is because the default sorting algorithm used is a quicksort algorithm. This algorithm is not stable, meaning that the original order of the equal elements may not be preserved. This can happen especially when you have multiple calls to the sort values function in a row. If this happens to you, you can try to change the sorting algorithm to a stable one. Let's see if this makes a difference. So now I'm changing to the stable algorithm, and let's rerun the code again. All right, we can now see that for the first delivery day, the factory order is respected. Meltdown factory comes first, followed by the radiant rims factory. And then lastly, still for the first delivery day, we have ForgeWorks. And this order is respected throughout the different delivery days. All right, I think this concludes tip number 3. Hopefully now you have a better understanding on how the sort function works in Python, both for the built-in function, but also for our example using data frames.